Welcome to Study Loop.
This is the answer to chapter 13, problem number 20. And so for problem number 20, we're given some pieces of spectroscopic information and asked to make some determinations about the structure of an unknown molecule. And problem number 20 focuses specifically on IR. So the IR that we're given shows major peaks at roughly 3000 wave number, which corresponds to CsP3 hybridized hydrogen bonds. And so you know, the majority of molecules that we encounter in organic chemistry have CsP3 hydrogen bonds in them. And so that doesn't really tell us much. What does tell us a lot is the other peak, which is at roughly 1700 wave number. And that corresponds to a carbon double bound to an oxygen. And those are really the only major peaks of interest above 1500 in the IR that we're given. So then we're given four structures, A through D, and we're asked which of them can be excluded based on the IR that we were given. And so A cannot be excluded because it fulfills the criteria. It has the two types of bonds that our IR says that it should have. So A cannot be excluded. B, however, has an alcohol in it, and the IR very clearly does not show the OH bond of an alcohol. Remember, that would be roughly 3200 to 3600 wave number, and there's nothing there. So we can exclude B. B is definitely not the answer. So let's cross B out. C also cannot be excluded. It has a carbon double bound to an oxygen. It has some CsP3 H bonds. And so on the basis of IR, we cannot exclude C as a possible answer. And then when we move to D, lastly, again, we see that, so D doesn't have an alcohol, but it does have a carboxylic acid. And remember that a carboxylic acid should show as a broad peak between roughly 2500 and 3500 wave number. And we don't have that. The only thing between 2500 and 3500 is the CsP3H, and again, the OH stretch is going to be a very distinctive, very very broad signal, and we don't see that. And so we can disqualify D as well. And so the final answer to this problem, I'll just box it over here. So IR allows us to disqualify B and D as possible answers, but we are still left with A and C. And this is important because it's a pretty good summation of IR. IR is very useful for telling you what functional groups are in a molecule, but as far as definitively proving the structure of something, IR is not up to that task. And later on, when you get to NMR, you'll see that NMR is much better because NMR can definitively prove what molecule you have. IR can only tell you what functional groups you do, or in this case, do not have in your molecule. And so that is the answer to number 20.